Right, let's see if we can draw this molecule. The molecule is 3 fluorobutane. So it's got a bromine group and a fluorine group, or sorry, atom, bromine atom, fluorine atom, and it has 4 carbons in the main chain. So the first thing I do is draw 4 carbons in the main chain. Then coming off the second carbon, I'm going to draw a bromine, and off the third, I draw a fluorine, and then I go around and I add hydrogens to every carbon to make sure that every carbon has its allotment of 4 atoms bonded to it. And I check at the end that they do have 4 atoms bonded to them. Okay, so this molecule is called trans 4,5 dichloropentene. So I'm going to start with the 5 carbons in a row for the pentoene, and I'm going to put the double bond off the second carbon. I'm then going to go back. So starting numbering from the side where the double bond is, I'm going to number all the way to the left and put the chlorines on the fourth and the fifth. There's the carbon right on the left and next to it, and the carbon next to it. Then going to add in all of the hydrogens, making sure in the double bond that the hydrogens are placed opposite each other, so we have the trans geometric arrangement, and then check that I have all of the hydrogens I need for this molecule. Okay, so this molecule is a geometric isomer. It has the cis arrangement. So the halogens are going to be coming off either both the top or the bottom. I'm going to put them both off the top. I'm going to draw 2 carbons with a bromine off the first and a fluorine off the second. What I'm going to make sure that happens here is that what I remember with these halogens is the halogens are similar because right, I'm going to draw this molecule, but I'm going to draw it in a condensed form. Now, in a condensed form, instead of showing all the hydrogens sticking out, I'm going to put them just to the right and put a wee number down, a wee subscript down the bottom right to say how many there are. So once I draw all 6 carbons, I'm going to draw off the second carbon, a bromine for the bromo. Off the 4th carbon, I'm going to draw my ethyl group. Notice that the 2 bromine has the smallest number because it has a higher priority than the ethyl group. Okay, let's draw this molecule. Again, I'm going to draw this in a condensed form. We're going to draw 4 carbons in a chain because it's a butane. And then I'm going to draw the fluorine groups from the trifluoro coming off, 2 fluorine groups coming off, atoms, 2 fluorine atoms coming off the second carbon and 1 coming off the third. Once I've done that, I'm going to come and fill in the hydrogens. Remember, the hydrogens at the end, if they've got nothing else attached, are CH3s. I don't need any more hydrogens for my second carbon because I already have 2 fluorines coming off. Okay, so let's see if we can draw this molecule, 2,3-dibromopentane. We're drawing 5 carbons in a row. I'm going to leave space to put the hydrogens in a condensed form. I'm going to draw my bromine atoms from the bromo groups coming off the second and third carbon. And then I'm going to go through and make sure each carbon has the correct number of hydrogens next to it. So we have CH3, CH, CH2, CH3. And the reason we have less off the second and third is because we have two other bromines attached, respectively. Okay, so we don't see these very often, but let's see if we can draw but1-ine. Remembering that a YNE is a triple bond. So but is 4 carbons, so I'll draw 4 in a row. And coming off the first carbon, I'm going to draw a triple bond, and therefore it will only have 1 extra hydrogen coming off it. The carbon that is the second one, we have no hydrogens coming off it because it has 3 carbon bonds to the left and 1 to the right. We go and add in the rest of the hydrogens to the molecule, and we have Okay, let's draw this molecule, 1-bromo, 2-methylbutane. Again, we're going to draw this in a condensed form. So I'm going to draw 4 carbons. I'm going to leave a wee bit of space to put the condensed hydrogens in. I'm going to draw a bromine for the bromo coming off the first carbon, and a CH3 for the methyl coming off the second carbon. And now I'm going to add in all the extra carbons, hydrogens I need to, but I'm going to place them just next to the carbons, and I'm going to put a wee subscript down the bottom right. Okay, let's see if we can draw this molecule. This is dibromomethane, so it's just 1 carbon, so we're going to put the carbon in the middle, and then because it's dibromo, there are 2 bromine atoms. We'll put them off that single carbon, and we'll complete the molecule by adding 2 more hydrogens. Okay, 1-chloro-4-fluoropentane. We draw 5 carbons in a row, leave space to write the hydrogens in if I'm drawing it in a condensed form. I'm going to draw a chloro off the first carbon and a fluoro off the fourth. And then I will add in the hydrogens to the condensed form. And the right number of hydrogens, so there will be 4 bonds coming off each one. So the first carbon has 2 hydrogens, the second 2, the third 2. The fourth has just 1, and then CH3 at the end. Notice, even though we've got a fluorine, if we could have numbered this the other way, which is 5 chloro, 2 fluoro, but that would have given us bigger numbers, so it's always going to be named in a way that we get this lowest possible numbers when we have similar groups.